So in this video I'm just going to have a look at Junior Cert Higher Level Maths Paper 1 2017. So this is it. This is question 14 and I will do question 15 as well. So in question 14 it involves this table here which has some information about regular polygons. Regular polygons are shapes where all the angles are the same size and all the sides actually are the same size as well. So for example, in the first case here we have a triangle. So we're going to have a triangle that looks something like this. All the angles are the same size, so they're going to be 60, 60 and 60 degrees. So all the sides are the same as well. These three sides are the same. The second shape here you can see has four sides, so if all the sides are the same, if all the angles are the same, all the sides are the same, it's just really going to be a square. So all these are same size and each angle then is just 90 degrees. Okay, so the first, we've got three columns here. We have the number of angles. In this column we have what you get when you add up all the angles in this column, and then we've got the size of each angle in this column here. So actually I've already done the first one here. Here is going to be 90 degrees. But the first question actually asks us to complete the column in the table above showing the sum of the angles in each of these shapes. So we've got to fill out this column here. Now we're told that the sum of the angles increase in a linear pattern. So linear is where you add the same number to each number to get the next number. So our numbers are 180 and 360. So we got to work out the next two. So we know that we're adding 180 degrees to each term. So if you add another 180 degrees here, that'll give us our next term here, which is actually 540 degrees. And if we add another plus 180 here, this is 180 here, we get 720 degrees. So let's just put those in. So we have 540 degrees here and we have 720 degrees here. Okay, so that's the first part of the question done. Let's look at the next one then. Find a formula for the sum of the angles in a regular polygon with n angles. Remember that these values follow a linear pattern. Now we got to find a formula for this here. Now there's a couple of ways of doing this, but what I'm going to do is, normally when you have a linear pattern like this, you write your formula down first of all as, normally what you do is write your formula down as Tn, or in our case the sum of the angles is going to be equal to whatever the first difference is. In our case it's 180n. Let's just see, does that work? Well, n is the number of angles in a polygon. Now in our first case n is 3. n is 3 here. So if we multiply 180 by 3, if we multiply 180 by 3, we get 540 degrees. Now our first term is not 540, it's 180. So we got to change this to 180. How do we do that? Well, if we subtract 360 degrees, that should work. So if you take 360 degrees from 540, you will get the first term. Let's just see, does it work for the next one? Let's take n is equal to, well, let's take n is equal to 5. We'll see if it works for the third one. N is equal to 5. So for n is equal to 5, the sum of the angles would be 180 times 5 minus 360. And if you do that, I'll just do it quickly on my calculator. 180 times 5, that equals 900. Subtract 360 degrees, you get 540 degrees. You get 540 degrees. So is the third term 540? Yes, it is. So this formula here does actually work for us. This one here should work for us. The sum of the angles is, so I'll just write it out actually properly. So the way you would write this out is the sum of the angles is equal to 180 times n minus 360, where n is equal to the number of angles in the polygon. Okay, so that's it. Now let's just have a look at the next part. Presumably we'll have to fill this column out as well. So let's just see, is that the case? Complete the column in the table above showing the size of each angle in each of these shapes. Remember that in each polygon all of the angles are the same size. So that should be straightforward enough. We can see here we've got 180 degrees with 3 sides, so divide 180 by 3, you get 60. Divide 360 by 4, and that will give you 90 degrees, because remember we have 4 angles here, so they all add up to 360, so divide by 4. Divide 540 by 5, and that will give you 108 degrees. Divide 720 by 6, and that will give you 120 degrees. So these are the size of the angles in each of these shapes. Last question then in this, that was this part here. Find a formula for the size of each angle in a regular polygon with n angles. Now what did we do? We took the sum and we divided it by n. So take any of these sums here, divide it by 5 in this case, divide this one by 6, divide this one by 4 to give us these numbers here. We have a formula for these, so all we've got to do is take our formula and divide it by n. So in other words, the formula, or the size in other words, so I'll write down size, this in white, size of each angle in a polygon with n angles is just going to really be equal to the formula that we worked out. That gives us the sum of the angles, so it's 180n minus 360. All we did was divide by n, divide by the number of angles. So if there are 6 angles, you divide by 6, 5 angles, you divide by 6, and so on. If there are 3 angles, we divide it by 3. So this is really it. That's it for question 14. So let's have a look at question 15. This is question 15 here. The 3 curves A, B and C are shown in the coordinate diagrams below. 2 of the curves show a function of x. So 2 of these are functions. Put a tick in the correct box to show which curve is not a function, does not represent a function in x. Give a reason for your answer. Well, I'll just do it straight away and then explain why. So it's going to be C here. So the answer here is C. So what's the reason for that? Well, the reason is that what you need to really know what a definition of a function is. And a function is where each input has only got one output. Each input will only have one output. So in this particular case you can see that your inputs are your x values and your outputs are your y values, if you like. So each input, so if we take any input along here, it will only have one output. Each input here will only have one output, will only have one y value. However, here if we draw a vertical line, say down along here, you can see that this particular x value here, in this particular case, this particular x value here will have an output here. It will also have an output here, and it will also have an output here. So if you put this particular input, this particular x value into your function, you'll get 3 different answers, and that doesn't work. It's like taking your remote control for your television and programming button number 1 to give you two different television stations. So you press button 1 on your remote control, two different stations will come up. Well, that's impossible. Only one particular television station will come up on your television. So this here is not a function, whereas these are functions. For any particular x value here, you will only end up with one output. This thing here is actually called a vertical line test for functions. So if you draw a vertical line anywhere along here, it will hit the graph only once. Same here, if you draw any vertical line along here, it will hit the graph only once. So these two are functions. This one here is not a function. So let me just write that out. So we would say something like in graph C, if we draw a vertical line, as shown, at x, we'll say, we see that it hits the curve in three different places. So x has three different outputs. Therefore, what we'll say, C is not a function. And you can go on to explain a function is where each input, in this case x value if you like, has a single output. So in a function, every x value will only have one output, or one y value. Okay, so that's it for questions 14 and 15, and in fact for paper 1 2017.